Dear learners, welcome you all to this video of Unit 5 Part 3 Progressions of the course 19 EY 710 Quantitative Ability 1. So previous videos on algebra and ages you must have gone through, and this is the third part, the same video of part 3 which is on progressions. So in this video we are going to see questions based on arithmetic progressions and geometric progressions. Let's get into the video quickly. So arithmetic progressions, it is nothing else but a sequence of numbers where the difference between the terms are constant. Say for example, 1, 2, 3, 4, 5 is in a series. The difference between 2 and 1, that is the second term. See, 1 is my first term, 2 is my second term, 3 is my third term, 4 is my fourth term, 5 is my fifth term, and so on. And the difference between the terms, the second term and first term, is the same as the difference between the third term and second term. Again, it is the same as the difference between the fourth term and the third term. So likewise, the difference between the consecutive terms are all same. If that is the case, we would say that this particular progression or the series follows a arithmetic progression. So there are two types of AP. One is finite AP and also an infinite AP. So simple, as in the name suggests, finite AP is that we know the last term of the progression, whereas infinite AP just goes on. We do not know the last term, simple. And it is not necessary that I always have to have the progressions in the increasing order. I may also have progressions in the decreasing order. For example, I can also say that a series of numbers like this 100 and 80, 60, 40 and 20 is all this also follows arithmetic progression, because the difference between these two, 80 minus 100 is minus 20. So I have a common difference of minus 20. So that's how I usually proceed. 60 minus 80 minus 20, 40 minus 60 minus 20. So it has a common difference of 20. The difference between the next term, the next consecutive term, the previous term is all the same. So we call it as arithmetic progressions. So the general form of arithmetic progressions is this, that is the terms are as A as your first term, A plus D as a second term, A plus 2D as a third term, A plus 3D as a fourth term, and so on. So the nth term is always given by Tn, which is equal to A plus n minus 1 into D. For example, if I say the third term of AP is 20. So when I say the third term, I would say T3, which is equal to A plus 2D, n minus 1. So n is 3 here, so 2D equal to 8 or whatever. The third term is 8, so I will say A plus 2D is equal to 8. If the fourth term is 16, then A plus 3D equal to 16. So like that it goes. And same way the sum of the terms is given by Sn, which is n by 2 into 2A plus n minus 1 into D, where A is the first term and D is your common difference. Same way, if we go for geometric progressions. So the general form of the geometric progressions, like how we had in arithmetic progressions, it is A plus D, A plus 2D and so on. So in geometric progressions, the general form is A into R, A into R square, A into R cube and so on. So yes, you're right. So there we have a common difference and here we have a common ratio. So common ratio is nothing else but the ratio, that is AR. See, I would say I would take A. So if I take this series, which is AR square, AR cube and so on. So this is my second term and this is my first term. So the ratio of the second term to the first term is same as in the ratio of the third term to the second term. So that's the eligibility criteria to be a geometric progression. That is AR by R should be same as AR square by AR. Naturally they are. Okay, so this goes off and yeah, AR by A. So I'll get a ratio, common ratio is R, and same way when I cancel them out, this also goes off, I'll get a common ratio. So the ratio between the second term to the first term should be same as the ratio between the third term to the second term, and that's the criteria to be a geometric progression. And like in arithmetic progression, we also have Tn is given by A into R power n minus 1, that is nth term. Again, if I say nth term or 8th term of the geometric progression is 12. So 8th term is T8 is given by A into R power 8 minus 1, which is 7. So this is equal to the any concerned number that's been addressed. And same way the sum of the progression, sum of the terms is given by a into r power n minus 1 by r minus 1. So these two is fair enough to solve any question based out of geometric progressions. So let's get into the questions. The first question is here, which is in the following AP series term at position 12 will be. So your progression is given. The progression given here is 4, 8, 12, 16, 20 and so on, and it goes on till 60. It goes on till 60 and we are supposed to find the number which is termed at position 12. Nothing else. T12 is what we are supposed to find. So T12 is a plus n minus 1. N takes the value of 12. 12 minus 1 is 11. 11 into d. And a and d we can easily find from the given progressions. So the value of a is 4. So a is 4 and common difference is 12 minus 4 or sorry 8 minus 4 or 12 minus 8 or whatever, which is 4 indeed. So if we directly substitute the values here, it's 4 plus 11 into 4, 44. 44 plus 4 is 48 and that is option C. So, and the next question is here, an arithmetic progression consists of 50 terms, of which the third term, so third term, I'll directly take the values, third term is 12 and the last term is 106. Since it is 50 terms and it is given as last term, so naturally T50 is 106 and I'm supposed to find T31. Okay, so let's put it out easily. So T12 is given by, sorry, T3 is given by A plus 2D. A plus n minus 1 into d, 3 minus 1, 2d is 12. That's my equation 1. And here it is a plus 49d is 106 and this is equation 2. So directly we can take 2 minus 1. So 2 minus 1 gives us a and a goes off. 49 minus 2 is 47d equal to 106 minus 12. 106 minus 12 is 94. So 94. The value of d becomes 94 by 47, which is just 2. So since d is 2, let's substitute it in 1 and find a plus 2 2's is 4 equal to 8, sorry, equal to 12. So a should be equal to 12 minus 4, that's 8. So a is 8 and d is 12, that's all, it's done. So we are supposed to find T31. T31 is given by T31 is a plus 30 into d. A is 8 plus 30 into 2 is 60. 60 plus 8 gives you 68. Do we have this on the option? Yes, it's option B. Okay, 68 is the 31st term. The next question. Find the number of terms of the given AP. So as it is, we have been told that this forms a arithmetic progression. 7, 13, 19, so on till 205, right? Let's take number of terms. So we are supposed to find the value of n. Let us first find a is 7 directly given and d common difference is 13 minus 7, which is 6. And this is the last term. So Tn is 205. If we find the value of n, we can say, or we can find how many terms are there. So only after finding the value of n, we will be able to find the number of terms. N is what we need to find in fact. So Tn is 1205. So I would take this as a plus n minus 1 into d as 205 and just substitute the values of a and d. Yes. So a is 7. So let's take it here. 7 plus n minus 1 into dd is 6 gives us 205 and then we can take n minus 1 into 6 is going to be 205 minus 7, which is 198. So n minus 1 is 198 by 6 and this is 318. 33. So n minus 1 is 33. The value of n should be 33 plus 1, which is 34. Okay, so the number of terms is 34 and that's option D. So all that is required to solve such questions is to understand what Tn is, what Sn is and where to apply which hint. So fair enough. Next question. Find the following sum. Okay, so here we just have the sum of numbers which is 2 plus 5. So I'll write down the number 2 plus 5 plus 8 plus 11 plus so on, and it goes on till 59. First we need to understand if they are in progressions, arithmetic progressions. Naturally, only with the help of common difference we should be able to confirm. 5 minus 2 is 3, 8 minus 5 is 3, 11 minus 8 is 3. So naturally the common difference is all same. So it follows a progression, arithmetic progressions. And sum of the terms is direct. Sn is n by 2 into 2a plus n minus 1 into d. So now you need to analyze now what are all the data required to find this. See, we have the value of, easily from the progression you can say a is 2 and common difference d is 3. So a and d alone is not enough to find the sum of the terms. You also need to know what n is. How do we find n? The last term is given, which is 59. So let's see which term it is. So if you find Tn, if you equate Tn to 59, where a plus 2 plus n minus 1 into 3 as 59, you can easily find the value of n. So n minus 1 into 3 will be equal to 59 minus 2, which is 57. So n minus 1 is 57 by 3. 57 by 3 gives you 57 by 3 is, so that tells you that the value of n is 19 plus 1, which is 20. I'm having a problem with the pen. Yes, I got it. So n equal to 20. So once I find the value of n, then I can easily find this. So 20 by 2, which is 10, and 2a is 4 plus n minus 1, 19 into 3. 19 into 3 is 57. Okay, so 57 plus 4, 61 into 10, that gives me 610, and that's the sum of the values, which is option A. The next question, find the sum of all natural numbers up to 100 which are divisible by 3. So this is a easy go question. Here 3, the next number, I am just writing the series 3, 6, 9, 12, 15, so on till, so natural number is divisible by 3, so up to 100. So my last number is going to be 99. Got it? So this is my first term, this is my first term, and this is my last term. Okay, and I'm supposed to find the sum of all the natural numbers. Sn is what I'm supposed to find. So two ways of doing this. I can take the value of n. So n should be equal to, see, this is my first term, second term, third term, and so on, and this is my 33rd term. Okay, 33rd term. So when you have the first and the last term only, you can also use this hint in order to find the sum of the terms is given by, only with the help of first and last term, the sum of the terms, just a second, sum of the terms Sn is given by n by 2 into a plus l, where a is your first term and l is your last term. So we know 33 by 2 and a is 3, 3 plus l is 99. So on calculating this, you get the answer, which is so you yes, and naturally this is what we need to find. So you get 102, 33, and by 202 also you can cancel them out and finally say 1683 as your answer, which is option A. Okay, so you can check for the calculations and revert if there is any discrepancy. The next question is here. The sum of 3 consecutive terms are in AP and decreasing order is 27. So sum of the terms is 27, and what else is given? Their product is 208. Their product is 208. See, let's put it this way. I'm going to take the terms as, and it is in the decreasing order. So let's say, okay, for example, I'm going to take 9 followed by 6 followed by 3. So these are in the decreasing order. So same way, let us take the general form of this progressions as n. So the first term has to be n plus d, and the previous term has to be n plus d, and the next term has to be n minus d. Okay, so this is how I am going to take, or I can take this as x plus d, x minus d, or a plus d, a minus d, however. Okay, and it is given that the sum of these consecutive terms, so n plus d plus n minus d, this is equal to 27. So we can cancel all this d, so 3n equal to 27, wherein I can say that n is 9. So the value of n is 9. All now we to do is find the common difference. Okay, and the product, so when I take product, it is 9 into the previous number is 9 plus d, and the next number is 9 minus d, and this is equal to 288. So I'll take 9 plus d into 9 minus d will be equal to 288 by 9. So we can cancel them off and say 27 is 3 times 18 to 32. Okay, so it is in the form of a plus b into a minus b, so a square minus b square. 81 minus d square is 32, and we can take d square as 81 minus 32, which is equal to 49. Okay, 81 minus 32 gives you 49. So the value of d, I'll write here, the value of d is 7. And what are we supposed to find? Find the three terms. So three terms is, the first term is a plus d. N plus d. N is 9. 9 plus 7, it is 16, and then 9 and 2. Okay, so these are the numbers, which is option D. 16, 9 and 2, option D. The next question. So we are entering geometric progressions. So if fourth and eighth term of GP are 24 and 384. So fourth term is T4. T4 is given by A into R cube. This is 24, and T8. So T8 is A into R per 7, and this is given by 384. So let's take this as 1 and this as 2. We are supposed to find the common ratio and the first term. Okay, so let us divide 1 by 2. So 1 divided by 2 gives you a into r power 7 divided by a into r cube will be equal to 384 divided by 24. So 384 by 24 is on one side. I'll take these two off. So r power 4, 7 minus 3 is 4. R power 4 gives me 384 by 24, which is So we got r power 4 as 16 and the value of r as 2. So when the value of r is 2, we can substitute it in the second equation because that goes with the easy number and find. So we got a as 3. So r is 2 and a as 3. Right. So when it is the respective numbers, when it is asked for the common ratio and the first term, it has to be the common ratio and the first term only. 2 and 3 should be your answer. You also have 3 and 2 in your option choice, but be very careful about taking the numbers respectively. Next question. So it is given that the ratio of the seventh term to the third term. So T7 is to T3 is given by 12 is to 5, and we are supposed to find ratio of 13th term to the fourth term. Okay, this is what we need to find. I'll take this as a plus 6d by a plus 2d will be equal to 12 by 5. Now cross multiply, 5a plus 30d will be equal to 12a plus 24d. Okay, so you can bring all the a's together. So 12 minus 5 gives you 7a and 30 is 6d. So d will be equal to 7 by 6a. Okay, so this is the relation between d and a. And we can take it this way. T13 is a plus 12d divided by a plus 3d, and this is a plus 12 into, in the place of d I'll take 7 by 6a divided by a plus 3 into 7 by 6a. right? So this goes off, I'll take this off, this is given by 2 and this is 2 again. So we can take it as a plus 14a, 15a divided by a plus 3.5, 1 plus 3.5 is, or you can take it as 2a plus 7a, so 9a, and multiply this by 2. So this is 30 divided by 9, or I can still say 10 by 3. So 10 is to 3 will be your answer choice. So we just found the relation between D and A and we are substituting it to find the ratio indeed. The next question is here, the sum of the series in AP is 525. Okay, sum of the series in AP. So Sn is given by 525. If the first term is 3 and the last term is 39, find the common difference. So 525 is given by n by 2 into the first term plus last term, the same formula we saw in the previous case, 3 plus 39. So 3 plus 39, and from which I can find the value of n. So 3 plus 39, or n equal to, or let me put it here, this is 42, n by 2 into 42. So 42 if I take, this is 21, and n should be equal to 525 divided by 21, and that gives you 25. So the value of n is 25. A common difference we need to find. So common difference, how do I find? The value of n is 25. So let us take it this way. So 25th term is 525. The last term is 39. No? So 25th term is 39. So T25 equal to 39. So A plus n minus 1, 24 into D equal to 39. And A is, so A is 3. 3 plus 24 into common difference equal to 39. So D should be equal to 39 minus 3, 36 by 24. That is nothing else but 2 by 3. Sorry, 3 by 2. 12. I'll take it in 12. So 3 by 2, option B. Option B is your answer. The next question. The fifth term and third term of a GP is 256. And respectively, of course, find its eighth term. So let's take a power r plus, r power 4. So that's the fifth term by a r 2, that's the third term, is given by 256 by 16. So we can directly cancel them off, which is 16. A goes off. So this is r square. R square is 16. So the value of r should be 4. So since r is 4, we need to find T8. T8 is given by a into r power 7. Okay, so a, let's find a here again. A into r square is 16. So as we know, a r square is 16. So a into 16 is 16. So the value of a should be equal to 1. So here I take 1 into 4 power 7. So 4 power 7, of course, should gives you 16384, and that is option E. The next question. Find the sum of first 11 terms of a GP. The GP is given, which is 1 minus 1 by 2, 1 by 4, minus 1 by 8, and so on. Right? So let's find the common difference. The common difference is minus 1 by 2 by 1, which is just minus 1 by 2. Sorry, common difference, the common ratio. The common ratio is minus 1 by 2. So when you have the common ratios minus 1 by 2 or less than 1, so directly we can take sum of 11 terms. So S11 is given by a into r power n minus 1 by r minus 1. So we are directly going to substitute the values. 1 into 1 minus of minus 1 by 2 power 11 divided by 1 plus 1 by 2, which is just 3 by 2. So I leave this to you. I want everybody to just work this out and choose the correct answer option and give in the comments as your answer choice. The last question. No, I guess you have one more question. So what term of geometric progression is 512 by 729? So here we know, the value of a, the first term, a is 18, and r also you can find minus 12 by 18, that gives you minus 2 by 3. So this is the common ratio, and Tn is given as, last term is 512 divided by 729. So Tn as such is a into, that is your 18, a into r power n minus 1, that's nothing else but 18 into minus 2 by 3 power n minus 1. So 512 divided by 729 should be equal to, in the place of 18 I'll take 3 square into 2, 9 into 2, 3 square into 2 power minus 2 by 3 whole power n minus 1, and 512 also I can write as 2 power 8, and 729 also I can write as 3 power 8. 729, sorry, 3 power 6. Okay, so this is 3 power 6. Now you can cancel them out because 2 power 8, this is 2 power 9. So when you cancel, this becomes 3 power 8. So this is equal to 2 power 8 divided by 3 power 8, and that is minus 2 by 3 the whole power n minus 1. So finally I would say n minus 1 is equal to 8. The value of n is 8 plus 1, which is 9. So this term, what term? It's ninth term. It tends to say that it is ninth term. The last question of this video. Find the sum of the infinite sequence. Okay, so like in arithmetic progressions, you also have finite and infinite sequence in geometric progressions. So remember, sum of infinite GP is given by, okay, so let me write it here. Sum of infinite GP is given by S equal to A divided by 1 minus R. That's it. So A is 7 divided by 1 minus R is minus 1 by 7. So 1 plus 1 by 7. And that gives you 49 by 8, which is option E again. Okay, so with this, your progressions is all over. I mean, these are the sample questions of your arithmetic and geometric progressions. Practice a lot of questions in this way so that this becomes very easy. So for any doubts or clarifications, you can always leave your comments. Thank you.